Hi, everyone. My name is Dave DeLong. I'm really excited to be here at my first UIKonf. I've wanted to come here for several years, but haven't been able to. But I'm thrilled to be here this year. As I was thinking about what I should talk about, I normally talk about app architecture. But as I looked at what the other speakers are going to talk about, I saw that we already have a bunch of really great architecture talks, so let's do something else. So I made a brand new presentation for you guys. It's called The Laws of Magic. And with the laws of magic, I'm not talking about magic of just like, ooh, that's shiny and sparkly. I'm talking about like, you're reading a good fantasy book, and there are dragons and wizards and sorceresses and elves, and there's magic. Now, there are some laws that govern how to make interesting magic. But first off, why should we learn about magic? Well, as we know, we deal with some really advanced technology. And there's a really fantastic quote by Arthur C. Clarke that says, "Any sufficiently advanced technology is indistinguishable from magic." If you were to take an iPhone and send it back in time, even 50 years, its capabilities would seem like magic to those people, just as something like a wand from Harry Potter might seem magic to us. So what is this iPhone, right? Well, when you get right down to it, it's a bunch of sand. There's some metal in there too, and a few other weird minerals. You mix those all up in the right way, and you get an iPhone. So how does it actually work? I came across a tweet that succinctly explains how it works. A CPU is literally a rock we tricked into thinking by putting lightning in it. It's magic. And we can do cool things with these iPhones. With the apps, I can learn about anything that I want. I don't have to go anywhere. I can just bring it up, and it magically appears. I can buy anything that I want from pretty much anywhere on Earth, with the exception of maybe Antarctica. I can make lots of money with an asterisk, because I kind of have to be lucky. But I can make lots of money with an iPhone. I can communicate with other people via outer space. And this is really cool. I think outer space is super interesting. So the fact that I have a device that I can use to communicate via outer space is magic. I can make strangers do things. I can pull out my iPhone, and some random person is just going to drive up to me and take me anywhere I want to go. I can use a service like Mechanical Turk from Amazon, and I can make people translate, for example, classic novels like Moby Dick into emoji. With my iPhone, I can even save lives. I can learn about first aid. I can call 911. I can help people live a better life. And this isn't even touching on the magical things that we can do with VR and AR. Now, when we build apps like these and we talk to other people about the cool things we do, they're like, wow, how does this work? And you're like, well, actually, and then you go into like this 3-hour-long explanation of how it works, and their eyes glaze over. They don't want to hear about. So usually it's just easier to say, it's magic. So, in this talk, we're going to learn about embracing our inner wizards. We're going to learn about 2 different ways that we use magic. There's the way that we consume magic by using apps and libraries, and then there's the ways that we produce magic by making apps and libraries. Now, when it comes to talking about magic and the rules of magic, in my opinion, there's no one better qualified to talk about this than a guy named Brandon Sanderson. Couple of enthusiastic clappers, that's awesome. If you don't know who Brandon Sanderson is, he is my favorite author. He mostly writes fantasy books. If you're familiar with The Wheel of Time, he wrote the last 3 books after the original author died. And he has written a whole bunch of other things. In the 10 years he's been publishing stuff, he's written over 46 works. He has another 40 that he's already publicly committed to. And because of this, he's a New York Times bestseller, he wins lots of awards, and so on. And he happens to live like 5 miles from my house. He's like the only author where he will announce a new book and I will just pre-order it. I don't care what it is, I will pre-order it. And I will buy it in like 3 different versions. I'll get like the ebook and the hardcover, and then he does like 10th anniversary editions. Like I buy them all because I want him to keep writing. Now, when he's writing books, he has 3 laws of magic that he follows to build engaging magic systems. These are systems of magic that capture your interest and draw you into the story. So we're going to go over these 3 laws and see how they apply to the magic we create. So the first law of magic, it says, an author's ability to solve conflict satisfactorily with magic is directly proportional to how well the reader understands said magic. This is long and complicated, so let's pick it apart. So the first law of magic first depends on an author's ability. And it's an author's ability to do a specific thing, and that is solve problems. But not just solve problems, it's solve problems satisfactorily, or solve them in a way that is nice and pleasing, and it's good and makes sense. And an author's ability to do this depends not on your ability as an author necessarily, but it depends on the user's, the reader's, understanding of how it all works. So if you want a satisfactory solution to a problem, your reader, your user, has to understand what's going on. Now, there are times we deal with unsatisfactory solutions, when we're confronted with problems and they get resolved and we don't like how they get resolved. When you're dealing with works of fiction, this is a trope or a cliché called deus ex machina, which literally means God out of the machine. And this is what happens when you're coming to the climax of a story and you have no idea how anything's going to be resolved, and all of a sudden, like, the heavens open, God steps out, waves his hand, and everything's resolved. This is a really unsatisfactory solution. You've put in all this time and emotional investment into the characters and understanding what's going on, and it's just kind of like falls flat, and you're like, really? That's it? You feel extremely frustrated. You feel like you've wasted your time, and you usually abandon the story and don't come back to it. In the case of software, we want to avoid these sorts of solutions. We want to avoid the feeling that our users are wasting their time with our code and with our apps. When you come across these solutions, you sometimes think, I could do this better myself, which is sometimes a legitimate impetus for creating your own new magic. But we don't want our users to feel this way. When they feel this way, they generate a whole lot of support tickets, and that just takes time and money. And what takes even more money are refund requests, and lots of refund requests are not a sustainable way to building a business. And in addition to this, you get lots of 1-star reviews, which means that your app is less discoverable, you're less likely to gain more users, and you have to deal with reviews like this. This is a bit of a satirical review, but you can buy it on a mug to remind you. On the other hand, when we deal with satisfactory solutions, there are a couple of different reactions that readers and users have to a really well-crafted solution. The first one is like the whoa solution. And this is like, I totally get how it works, but I never saw this coming, and I am so excited because it was crazy and imaginative and it works so well. There's the, oh, well, of course it's that way. And this is a really great solution, or a really great reaction to a problem, because it means that we've done a really great job of teaching the users what they should be expecting. So when it happens that way, their expectations are met, and they're like, oh, well, of course it's that way, because that matches what I've seen so far. But in my opinion, arguably the best solution, or the best reaction, is none whatsoever. Because you have done a successful job of hiding the complexity and hiding the problem so well that nobody even knew they were problems. So we're going to look at two examples of solutions. The first one is an example, in my opinion, of kind of a bad solution. And it's the date and time APIs in Foundation. Now, if you're not familiar, I'll just say that calendar code is magic. Because it really is. There's so much going on, so many things you have to worry about that, like, when you see a proper solution, you just have like no clue how it works, and you're like, that's magic. Like, seriously, there's a day missing in the middle of a month? That's magic. Now, this isn't to say that the date and time APIs are bad. They're actually, in my experience, the most powerful date and time APIs available to any programmer on any platform, anywhere. But they're still hard to use, because no one uses them correctly. Why is that? In my opinion, there are two big reasons why the date and time APIs are an unsatisfactory solution. First, there's a lot of ambiguity. The date and time APIs are really focused around three classes: calendar, date, and date components. There are others like time zone and date formatter, but those are the three core ones. Since there are only three classes, you might think this is very focused and easy to use. You would be wrong. There is a lot of ambiguity, and that ambiguity leads to incorrect usage of the API. More fundamental than that is just the problem that the entire domain of functionality is so complex that the API doesn't hide it from you in any way. So anytime you deal with calendar math, that in order to do it correctly, you have to deal with the full complexity of the solution. This is unsatisfactory. It leads to a lot of frustration, and we kind of abandon it, and we're just like, OK, 86,400 seconds. I will move on with my life. On the other hand, an example, I think, of a satisfactory solution, or a solution that solves the problem well, is the measurement API. If you're unfamiliar with measurement and NS measurement in Foundation, this is an API for converting between units. Now, this seems like a pretty simple thing. You know, you can do any sort of unit conversion in pretty much constant time. That's nice, right? But the thing that I think is really cool about the measurements API is you can actually add your own units and types. So of course, there are all the standard units built in. Like, you've got the velocity domain, and you can deal with like miles per hour, kilometers per hour, and so on. But if you wanted, you could define, I need a new unit of measurement, furlongs per micro fortnight, and you could easily add that. And it would just work converting from kilometers per hour to furlongs per micro fortnight, which is actually a real unit. If you wanted, you could take it even further and add your own kinds of units. So you could add in a kind of unit for measuring radiation doses, such as, you know, grads versus, you know, Curies or whatever. No one has any problem using this API. The ability to define your own units and just make it work is kind of a complex problem, but nobody really has any trouble with it. Why is that? Well, first, this API is type safe. It's impossible to use it wrong, because the compiler won't let you build your app if you're doing it wrong. Also, it's extremely focused. It does one thing, but it does it extremely well. As we're building our own kinds of magic, we want to aim for the same thing: the safety, the focus, the inability to do things wrong. We have a few tools at our disposal. And our goal with using these tools is to minimize confusion and questions, because those are the things that lead to support tickets and refund requests. So one of our tools, of course, is conventions and familiarity. When we're building apps, we have things like the human interface guidelines that say, if you want to do navigation, then using like the standard push-pop navigation model is a great place to start. It's familiar, and anybody who comes into an app with a navigation controller instantly knows how it's going to work. On the code side, we have our standard architectural patterns. We have inline documentation. If I'm using somebody else's code and it all seems kind of magic-y and I want to know how it works, hopefully I can just option click on it and get a nice little pop-up saying, here's what this particular method does, here's what this type does, and the magic goes away, and it's all there, and I get a satisfactory solution. One tool I think we could take more advantage of is the compiler. And I want to give an example of this. Using the compiler, we can enforce that the only thing you can do with an API is what you're supposed to do. So as an example, let's go back to date and time code. And let's say we want to be able to do this. We want to take a value for this month, so this would be like May 2018. And this is not any particular day in May, it's just the idea of May as a whole. Now with this value of May, we can adjust it. We can add a month, we can subtract a month, and so on. We can't do anything with smaller units. We can't say add 3 days or add 3 seconds. Because what does it mean to add 3 seconds to May? This is not anything that makes sense. Yet it is something that the Foundation APIs technically allow you to do. And it's going to make up an answer. We don't want to allow this. What we want is, if we try to do this, to get a compiler error. And it would be really cool if we could even get a message teaching us that you're not supposed to add seconds to a month because that just doesn't make sense. What are you doing? We can do this, and it's actually not that hard. We do it by using unavailable annotations. So a simple example, in this particular one, if we want to teach people to not add seconds to May, we actually define that operator, the plus operator, to add seconds to May, or adjust a month by some second value. And we don't want this to be called, so we'll just say it returns never, because you have to have a return type. But then, in order to teach and make sure our users understand the magic, we can mark it as unavailable. And the availability annotations also allow us to provide a custom message such that when I try to use this in code, I'll get an error because it's unavailable, but I'll also get a message explaining why. So this is the first law of magic, that satisfactory solutions require our users to understand what's going on, which means it's our responsibility as magic creators to teach them. We can do that by following conventions, providing documentation, and only guiding them down the ways that we want them to go, and explaining why they can't go other ways. The second law of magic, my personal favorite, says limitations are greater than powers. What are the powers and limitations? Powers, fundamentally, are the things that we are able to do. I have the power to create apps. I have the power to, perhaps, do date and time code correctly. Limitations, then, are the opposite, things I can't do. And when it comes to creating magic, usually the limitations are more important than the powers. It's more important what you can't do than what you can. So let's take a look at some example powers. As app creators and library creators, we can do things like posting text to the internet. We can take pictures. We can write a story in an app as a user. We can play solitaire in an app as a user. And by themselves, these are kind of cool, but when you get right down to it, they're all just kind of boring. So let's add some limitations to these powers to make them interesting. So instead of just posting text on the internet, let's add a limitation that you can only post 280 characters on the internet. And now suddenly, this limitation forces you to be more creative. It forces you to think about what you're trying to say using fewer words. Or it could lead you down the path of, how can I exploit Unicode to add more Can I use ligatures to make it look like there are two characters, but there's still only actually one? Instead of just taking pictures, what about taking pictures that get deleted soon? Now suddenly, I don't have to worry as a user about like those pictures from that one party a few years ago coming back to haunt me. I can take pictures that allow me to communicate more authentically because I'm not worried about them coming back. I'm not worried about them being persisted. If I want to write a story, let's add a limitation. Perhaps that I can write a story, but if I stop typing for more than 5 seconds, the story deletes itself. This is an actual app. And the limitation this app imposes on you forces you to keep your mind working. And it forces you to keep your fingers working, because if you stop, you lose it. You set a little time limit, like, I want to write for 10 minutes, and then you write for 10 minutes. So it's a good way to teach yourself to become a writer, because you're kind of screwed if you stop. Or the example of playing solitaire. Well, you can play solitaire, but if you make a mistake, well, that's an in-app purchase. As a user, this is a particularly personal example for me. There is a version of solitaire on the store I love called Churchill Solitaire, named after Winston Churchill. And it is glorious and complicated and difficult, and undos are an in-app purchase. And this makes me feel extremely frustrated as a user. But it also forces me, as the player, to be extremely careful about my strategy. The idea behind all of these is that limitations force you into action. And it does that in 2 different ways. First is the idea, we have the proverb in English that necessity is the mother of invention. That if you need something and you don't have it, you are forced to invent something to get what you want. The second way we are forced into action has to do with this thing called choice paralysis, or sometimes called analysis paralysis. Good alliteration there. The idea behind choice paralysis is that if you have too many choices, it's impossible to make a decision. As an example, if you go to a restaurant and you have a 6-page menu of entrees, how do you choose what you're going to eat? You can't. You have to go through like 6 exhausting pages and try to think, oh, what do I want? Do I want this? Well, maybe I want it more than that, but I kind of like this here. What am I feeling today? And after like 10 minutes of staring at a menu, you're just like, give me a hamburger. So too many choices can sometimes be a bad thing, in which case limiting your choices can make it easier. So instead of dealing with a 6-page menu, perhaps you go to a restaurant where it's literally just, you can pick one of 4 entrees, at which point you're thinking, well, do I want a vegetarian option? Do I want seafood, chicken, or beef, right? And at that point, it's really easy. So in other words, the freedom to not have to choose can sometimes be more empowering than the freedom to choose. This is, I think, one of the things that makes Apple so successful. If you want a computer, you're really looking at, well, do I want to be able to carry it around? Okay, MacBook Pro. No? Okay, iMac. Like, it's easy. If you compare this to other manufacturers, you're like, oh man, I gotta go look at specs and CPU speeds and RAM and like all this stuff, and it's just like, who wants to deal with that? Freedom from choice is an interesting limitation that leads to action. So these are the second law of magic. If you find yourself stuck on a problem and you're not sure how to proceed, try giving yourself artificial limitations. Well, what if I tried solving it without having this at my disposal? Does that force you to think about the problem in a new way? As you're building an app, remember your limitations. Remember that I'm not going to add features that don't have anything to do with my app. So I have a power, but I'm limiting it. Because as you apply these constraints, as you deal with things like your photos get deleted after about a day, or you're only limited to a certain number of characters, or your text disappears after 5 seconds of no typing, you get some really interesting and really unique results. So that's the second law of magic. The third law of magic says, expand what you have before you add something new. In the context of like writing a book with a magic system, this would be something like, before you just kind of like decide to add a whole new kind of magic, see if you can do something interesting with the magic you already have. We can expand what we have by considering consequences. And there are a couple of different ways we can do this. We can ask ourselves, what happens if sorts of questions, like what happens if my user is using this app in this particular way? How am I going to deal with that? What if they're trying to use an Apple Pencil? What if they have less than 10% battery left? What if all of these things? What happens if? On the library side, what happens if I get a memory error? Is there anything I can do to be a better citizen? These all are questions that can change how we think about problems. There's also questions like, how can I make these different things work together? Can I integrate them somehow instead of keeping them as separate, isolated features of an app? Because our goal as library creators and app creators is to make the best possible thing. Raise your hand if you want to be a mediocre creator. One guy, two guys, okay, maybe three. We want to be the best at what we do. So the way we do that, we need to go deeper. I want to give you a couple of examples here of going deeper. The first one is one of my absolute most favorite apps called Deliveries. Deliveries, on the surface, is an extremely simple app. It's package tracking, like you buy something off Amazon and it will tell you when it gets to your home. Really simple, but it does so many neat things that just make it indispensable. For one, it works with just about every package delivery system in the world, and even like handoffs between systems. So if you order something and it is coming via the Royal Mail and it gets transferred to UPS and then like USPS for the last mile, it'll just work. But more than that, it does a bunch of other things. Like if I have an email that I get with a shipment notification and I copy a paragraph that has a tracking number inside of it, I can just take all that text over to Deliveries, and the instant I open that app, it's going to scan the pasteboard, identify the tracking number within the paragraph of text, recognize what tracking system it comes from, and says, I found a UPS delivery. Would you like to add it to your list? That is so powerful. I can also do things like set up an email rule, where as soon as I get any shipment notification, I can just forward it to a creator's special address that I've associated with my account, and he'll just extract the tracking number automatically and add it to my account. That is super powerful. I get rich notifications. There are extensions. There's a Today extension. There's a Notification Center extension on the Mac. And even more importantly to me is there is a Mac app at all. We all spend most of our days sitting in front of a computer writing code. Why should we deal with an inferior experience using a browser when we can have a deep and engaging experience with a native app? Deliveries does this. A second example is an app near and dear to my heart, which is Keynote. This may sound kind of weird, but you'd spend enough time giving presentations, Keynote becomes super cool. And in my opinion, one of the coolest features of Keynote is this thing called outline mode. It will blow your mind when you see what it can do. We normally think of Keynote as dealing with slides, but it has this cool thing called outline mode, and I want to show it to you. So, all right, I've got a presentation here with some ideas. Now, these are ideas that I'm thinking about adding, maybe some, this will be a meta presentation of presentations I might want to give in the future. So I can go in here, and of course, I can do the Keynote thing of ideas for future presentations, right? And I can double click in here and start typing, well, maybe I want to do something on the measurement API. Maybe I'll brave the riots of the crowd and do core data. and other things. So like I can build presentations in this way. But if you go up here to the View menu, this is a standard navigator view. There is this thing called Outline Mode. And it changes the left-hand side to be this. And you think, OK, well, that's kind of cool. It just kind of shows like the title of the slide and the bullets. It is editable. So I can go in here and I can say, well, I also want to talk about date and time. And it just shows up in the slide. And I can go down to another line, but I'm like, no, this needs to be a higher level concept. So I shift tab to unindent, and now I'm dealing with a new slide. Non-technical things. Outline mode is a really fantastic way to quickly build presentations. But you can go further with this. So here's an outline of things that I really like. And they always say, you know, present what you know. Here are some things that I know. And I was thinking one day, well, I've got this outline. Can I do something with it? So like, maybe if I'm, say, well, I really like food. Well, I like chocolate. And I like peanut butter. And I like chocolate and peanut butter. It's like proof of the existence of benevolent deity. So, you know, I've got this outline. Well, I can just copy this outline, Command-C, go back over to Keynote, new slide, Command-V, and I get this whole thing. And there is a bug here in Keynote where it comes through as black text because it was black in Pages, but if I can just reapply the master to a slide, then it's like, OK, reset to the styles for everything. And now I've just got like instant creation of a whole bunch of slides. Like this is so cool to me that Keynote has this deep ability to help me make slides. So this is how Keynote goes deeper. So what are ways that we can go deeper? If we're building an app, if we're building libraries or frameworks for other people to use, I would say the #1 thing you can do to go deeper is to build in support for accessibility, localization, and dynamic type. And this applies whether it's an app or a UI framework. This is more than just about like adding some cool things. This is about making your product available to as many people as possible. There are people who won't want to use your app because they can't make the text size the super mega accessibility ultra huge size in system preferences. For whatever reason, maybe it's they have poor eyesight. Maybe they just don't want to deal with a whole bunch of stuff on the screen, so they make the text big to not have it be so overwhelming by having lots of little small things. Accessibility, localization, and dynamic type are a way to make your code available to more people. There's all the natural system integration that we might want to consider, integrating with Spotlight, so our data becomes accessible anywhere within iOS. If I'm on the home screen, I can just pull down the search field, start typing, and I can instantly find that custom data model that you've built into your app and jump straight to it. I don't have to like open the app, tap, 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 tap through like 14 different screens to find what I'm looking for. I could just search for it. I can hand off between iPhone and iPad or iPhone to a website. With extensions and Siri, I can make this information available in any place where it's contextually relevant. Maybe this is a Today widget. Maybe this is an iMessage extension, whatever. Wherever it makes sense for you to expand what you have before going off and just writing a new app. There's also integration with other apps. A really fantastic example of this is the app Drafts. On the surface, it's a really straightforward app. You open it up, you've got a text field to type in. But what you can do with this text is pretty mind-blowing. You can just, immediately send it off to messages. You can send it off to mail. You can send it off to reminders. You could save it as a file into Dropbox. You can have it perform other sequences of actions. And it's all focused on the core power of writing text. But instead of just leaving it at that, it's an app that goes deep with integration. Remember also that there are a whole bunch of other mobile platforms These days, the line between iPhone and iPad is getting blurred a whole bunch with multitasking, where an iPad app looks just like an iPhone app. So maybe it makes sense for you to build a full-on iPad app, maybe a TV app, maybe a watch app. And I would be remiss if I didn't say, well, what about a Mac app? Again, we spend hours every day sitting on a Mac. Our users deserve that deep and engaging experience. So this is the third law of magic, that we consider the consequences to add in deep integration so that we can build the absolute best possible thing that we can, so we can blow minds. So, the 3 laws of magic, hopefully summarized for you. You have to teach people how the magic works in order for them to be satisfied with how you use it for them. The limitations you experience are often more important at solving problems than what you're able to do. Finally, if you want the best experience, focus on a single problem and explore its depths. Now, like all good lists, this actually starts at 0, not 1. So if you follow these laws of 1, 2, and 3, you will inadvertently discover the 0th law of magic, which is to make it awesome. Thank you very much.
Thank you, Dave.